Back to Hamzy Beltech Virtual Laboratory. Today, we're diving into the fascinating world of digital electronics. Digital electronics is a branch of electronics that deals with the manipulation and processing of digital signals. Unlike analog electronics, where signals can take any continuous value, digital electronics uses discrete signals, typically represented by two states: 0, low, and 1, high. These binary states form the foundation of all digital systems. Let's get started with number system, codes, and code conversion. We'll explore the different number systems, how they're represented, and how to convert between them. Number systems are fundamental in computer science and digital electronics, as they provide a way to represent and process numerical data. Number representation. In any number system, the value of a number is determined by its digits, their positions, and the base of the system. Each digit represents a specific value based on its position in the number, starting from the rightmost digit. The rightmost digit is the least significant and represents the base raised to the power of 0, e.g., 1 in any system. Moving left, each subsequent digit represents the base raised to a higher power, e.g. base 1, base 2, base 3, etc. To calculate the total value of a number, multiply each digit by the base raised to the power of its position, then add all these products together. Conversion between number systems. 1. To convert binary to decimal. Write down the binary number. Multiply each bit by 2, position. Starting from the rightmost bit, position equals 0, sum the results. 2. To convert decimal to binary, divide the decimal number by 2 and record the remainder. Continue dividing the quotient by 2 until it becomes 0. Write the remainders in reverse order. 3. To convert binary to octal, group binary digits into sets of 3, starting from the right. Add leading zeros if necessary. Convert each group to its octal equivalent. 4. To convert binary to hexadecimal, group binary digits into sets of 4, starting from the right. Add leading zeros if necessary. Convert each group to its hexadecimal equivalent. 5. To convert decimal to octa, divide the decimal number by 8 and record the remainder. Continue dividing the quotient by 8 until it becomes 0. Write the remainders in reverse order. 6. To convert decimal to hexadecimal, divide the decimal number by 16 and record the remainder. Continue dividing the quotient by 16 until it becomes 0. Write the remainders in reverse order. 7. To convert octal to binary, convert each octal digit to its 3-bit binary equivalent. 8. To convert hexadecimal to binary, convert each hexadecimal digit to its 4-bit binary equivalent. Practical applications. Binary is used in computer systems and digital logic circuits. Octal is commonly used in older computing systems and some microcontrollers. Decimal is used in everyday life and calculations. Hexadecimal is widely used in programming and digital systems for compact representation of binary data. It is time for us to practice. Convert 1011, binary, to decimal. In this case, 1011 equals 1 by 2 cubed plus 0 by 2 squared plus 1 by 2 plus 1 by 2, which gives us 11. Congratulations! You've completed practical 1. Continue to the next lab to explore Boolean algebra. Thank you for watching. Subscribe to our YouTube channel for more tutorials.